for joining us today. This is the first of the series on inclusive practices in mathematics, and this one is for the middle years, grades 6 to 9. And we have a similar series running for K to 5. These videos will be recorded and then uploaded to our YouTube channel. Today, we're going to specifically talk about Math Workshop. We'll talk about what is Math Workshop. We'll figure out how to sort of introduce it in a way that invites learners into the conversations. We will look at components of Math Workshop, provide 3 structures of it, and then give some examples of how it might look in various grade levels. So this whole series is centered around inclusive practices in mathematics. When we think about the students in our classroom, we want to think about how we can invite them into the learning and then support them with where they're at and think about how we might move them forward. There are specific frameworks and structures that we can consider when we are trying to build in some more inclusive practices into our math teaching. One that we will consider in this series is universal design for learning. If we just do a word explosion, universal really refers to everyone. It's that variability of our students, thinking specifically about their individual learning needs. And then when we consider what design is, it's planning and creating with intention. We want to ensure that we've got identified learning goals. We want to think about any of those barriers that might get in the way of learning, and then provide lots of options and choices for students to access the learning in different ways. And we'll talk about what those choices and options could look like. Then when we talk about learning, it's opportunities to work towards language and social goals and towards the identified learning standards. So here's an example. If we have a learning goal, we might think about activities that coincide or align with that learning goal, and then the choices that we might offer. So when we're doing anything related to Math Workshop, our learning goals might be that we want students to engage with concrete materials. We want them to be able to show and represent their thinking in various ways. One of them might be in pictorial form and symbolic form. We might also want them to work with integers or a specific topic of choice, and then show some ways of engaging with the learning by applying their knowledge. And they might do that through play. But all the while, we want to be listening into the conversations that they're having with their peers. So in an activity like Math Workshop, we can offer lots of different types of choices. We can offer choices when it comes to the questions that we're giving in terms of the way that students are representing what they know, sometimes in terms of group members when they can select what activities that they would like to do. That's optional. Sometimes I kind of pick the groups that I want students to be working with in order to maximize on learning, and I'll tell you more about that. And then we will also think about the choices we have in terms of spaces in the classroom. After we've sort of set up that structure, we want to also consider how we can differentiate our instruction to meet the specific needs of our students. So one way that we can do that in Math Workshop is through small group instruction, but it's also through the various questions that students are engaging in. So at all of the stations that we are working at, we can differentiate so we are providing access. When we think about inclusive practices in mathematics, we want to build on students' funds of knowledge and interests, create choice for where and with who students can learn, create choices in materials and access to tools and technology, create choices in questions students can engage with, and create choices for different ways for students to represent and share their learning. So when we talk about Math Workshop, we want to center our thinking and also share a little bit of history as to how it came to be. It's deep pedagogy that's built and enforces that thinking classroom. This is a quote by Peter Liljedahl, and it's that orange text that you see on the bottom left, which is his building thinking classrooms. It says a classroom that is not only conducive to thinking, but also occasions thinking, a space that is inhabited by thinking individuals, as well as individuals thinking collectively, learning together, and constructing knowledge and understanding through activity and discussion. So most of what we've based our sharing on today is grounded in these two books. The one at the top is by Jennifer Lemp and Skip Tyler, and it's called Math Workshop. This was a brand new one off the presses for grade 6 to 12, but there is a complementary book for K to 5 that has very similar structures in it, but also looks at how you can be teaching towards maturity and age group. So when we think about what Math Workshop is, it's a model for instruction. It builds community and opportunity for focused practice. It provides access for all learners, and students engage in rich mathematical discussions, and it provides time to grapple with math ideas. There are 7 kind of principles or characteristics of Math Workshop that Jennifer Lemp and Skip Tyler talk about, and sort of how we want to think about setting up our environment to create. We want students to be self-regulated in this process. And so that means that students are doing most of the math. Students are making their own choices. Students enthusiastically talk about math, and then they start to reason with each other to build their learning. We as teachers are involved in the facilitation, but mostly just to clarify, to create connections, to monitor, right? To get some of those formative feedback, formative assessment pieces that we are going to be influenced by in terms of creating our next steps as teachers. We also can collect data, which is evidence of learning. And we can sort of think about the tasks that would be rich enough for students to engage in. Right? This is also where students work collaboratively in that social learning aspect. Teachers allow students to struggle with challenging mathematics, right? It's important that we provide opportunities for students to stretch their thinking, come across struggle, and then learn the tools that they need to have in order for them to push themselves forward. And so we want them to have more independence with that. And then it gives us an opportunity to also, if we are so inclined, to work with small groups and individual students. So let's talk about the components of Math Workshop. The first one is on instructional routines, generally less than 20 minutes. Many of you might be familiar with these, but they're quick and engaging designs for learning. They're repeatable, very accessible, they're purposeful and connected to our learning goals. They encourage application of number sense and computational fluency, and they help all students connect with other knowledge so that they can make sense of this situation, the context, or the concept at hand. So I've got a list on the screen right now of ones that actually can be used across topics. The would you rather, same but different, which one doesn't belong, estimation 180, slow reveal graphs, and number talks are ones that you can really think about using from topic to topic. So students are getting familiar with the expectations and the rules associated with them so that they can engage in the learning faster. So if we start our Math Workshop with an instructional routine, we're getting students to gear themselves for the social learning in a more direct way. We have some resources for math instructional routines on RichNet. At the top of the screen, you'll see that under our Numeracy Foundations, there will be a little tile for instructional routines, and you'll see particular documents that give you some descriptions of what they are, but also links to websites that have access to particular questions. There's also our YouTube channel, our new Numeracy playlist for videos about instructional routines, and that runs from K to 9. And for an extra resource, you could be looking at that Coast Metro Elementary math project. And if you look at a particular concept, you'll get access to a 5-day plan. And in that 5-day plan, there's weaving of instructional routines, or even at the bottom, there's suggested links and resources you can look at to see which ones might apply to specific concepts. Another routine or another structure within a math workshop is a task and share. There's different names for this, like a numeracy task. When we talk about a task, it's an activity or problem that requires students to engage in mathematical thinking, practicing competencies, deepening understanding of the concept at hand. But we want to think about how to structure that. Usually students work in groups of 3. These are engaging thinking tasks that are low floor, high ceiling. They're contextualized so that students are practicing math in real life situations. They range, there's a range of acceptable solutions where then students are required to explain and justify their final answers using math. So when we talk about numeracy tasks or tasks and share, there's a lot of choice that we can be offering in terms of where students do the work with their peers. This is one of the options. It's vertical non-permanent spaces. And if you're familiar with building thinking classrooms and Peter Littledale's work, you will know a little bit about why this is encouraged. A lot of the times when students are sitting at their desks, there's an opportunity for them to sort of hide in their groups and not participate. What Peter Littledale states in his research is that when you get them out of their desks and working at a space around the room, whether it be on a whiteboard or a portable one, automatically you're to engage in the learning with other people, and it creates some sort of enthusiasm. Kids engage in discussion, they participate more, they persist more with the challenging questions. And then he talks about knowledge mobility, where they start to look at each other's work, get ideas, and then further their own learning. So vertical non-permanent spaces is an option, but not all students have to engage in it. They can just use individual whiteboards or sit at desks with partners, but it's a good way to offer choice. There are a number of resources for numeracy tasks that we can offer. There is Peter Littledale's site where he's created a collection of them based on age group. And Robert Kaplinski has a number of lessons that are also situational based. There is Math That Matters. Their blog has lovely situational context also where math can be applied. 3-Act Tasks by Dan Mayer. And Rich has lots of math problems. Mathematics Assessment Project does as well. And then I've shown 2 books on the bottom here called Good Questions for Math Teaching that also offer some. What you want to do and think about, though, is when students are in groups, it isn't really a one-size-fits-all problem. And so you want to think about how you might personalize the content within the problem for students so that they can get access. For example, if you're working with decimals in a grade 6-7 classroom and students are still working on building foundational skills, and we might need to change some of those numbers to whole numbers or things like that. So when we are involved in numeracy tasks, at the very end is the most important part, and that's the share. Our job in this process, when students are engaged in numeracy tasks, and that is as teachers, is that we're walking around, we're circulating, we're monitoring, we're kind of selecting who's going to be sharing what so that we can kind of scaffold what the learning is going to look like during that sharing process. So we're kind of sequencing that. And so there's some questions here for you to consider. How are you going to scaffold the thinking? What questions can you ask either to assess the understanding of the concept or to advance or deepen the learning, right? As students are beginning to share their solutions. Another component of math workshop is focus lessons. Generally, these are less than 15 minutes or 20 minutes. This is targeted instruction, something that you either want to teach the whole group at once, where there's a specific learning goal in mind or a concept, skill, or topic. It's an exploration, but students are doing the math. They're thinking and discussing, and we're inviting them into that process. And we just want this to be really bite-sized and digestible. So, the other component of math workshops is learning stations. Learning stations are called so many different things: centers, practice stations. And what you want to do is think about what's going to be most meaningful to create at each of the stations in relation to the learning goals that you have. And so you can use learning stations at any time you want to work with small groups of students, or you want to just provide opportunity for students to practice certain things. And so I always think about, how am I going to set this up if it's a very first time or experience in my classroom? There are some norms and expectations that you want to share with students so that they know what to do when they are working independently, particularly if you're working with a small group of students. Then you really want them to be independent and be on task. And so you want to think about how you would do that. And then think about what is going to be most meaningful for students to do during those stations, right? Design the activities, create choices, make sure kids are collaborating, they're moving around, and then it's an opportunity for them to build their self-regulation skills. So there's lots of resources to support in thinking about what to offer at each of these stations. Got a number of books listed there, but also on the blog, you will see that there are math games. There's also a tile on the Numeracy Foundation's framework that will lead to here for specific topics of interest. And again, our Numeracy channel is a good one for that too. So something to consider in a math workshop is if you're going to do have small group instruction, where you are just offering just right math instruction to a group of students, and you're able to differentiate and take the time to learn about students' strategies, their strengths, their stretches, their misconceptions, so that you can figure out what their next steps could be and how you might support them in getting there. But what is the most important part about Math Station is the part at the end around reflection and consolidation. You want to think about how students show what they know they can do in relation to the learning standards, right? How can students express their ease or challenges with the task? How can students share their strategies and processes? How can they reflect on and analyze their approaches for how effective it was and what they would do next time? And how can students compare ideas, right? So there are 3 particular workshop structures that Jennifer Lemp and Skip Tyler talk about in their book. We're going to look at a few of them, but what we want to be paying attention to are the particular curricular competencies practiced during those math workshop examples. Kids are going to be involved in estimating, visualizing, using mental and computational strategies. They're developing mathematical understanding through play. They're representing ideas concretely, pictorially, symbolically, written ways, in oral ways. They're writing and justifying their thinking, and they're connecting math ideas to one another. So one of the structures that she offers is the task and share. In that, she says, start with an instructional routine, do the task and share, and then have students self-reflect. So here's an example. In grade 6-7 class on decimal operations, we started with a would you rather, then got into a numeracy task offered by Peter Liljedahl. You can modify these or adapt them. Sometimes taking the time to do the calculations for all the things on the page might be too much in the time period that you have allotted. And so you can just take a look at 2 of the pets, provide a graphic organizer to support thinking, provide a choice for how they wanted to do their work. And some use the vertical non-permanent space, some use desks, and then provide an opportunity for them to share and justify their solutions. Another component or another structure for a math workshop that's offered in the book is called multi-component. That's where you offer an instructional routine, you do a bit of a focus lesson, then you can engage in learning stations and have small group instruction happening at the same time, and then consolidate thinking at the end. So here's an example in grade 8 for multiplying fractions. We start with like an open middle question that has them looking at the concept of multiplying fractions. But the focus lesson was another way for them to explore how to multiply fractions, but to do it in a way that, helped them with their visualization. And a lot of the times for them to think about, if I multiply 2 numbers, is my answer going to be smaller than what I start with or bigger than what I start with? And how can I show that in a number line? And so this is a double number line activity that they engaged in. And then got into some learning stations. One of the stations was to continue with the clothesline activity. Another was to get onto some digital devices. They started to make a connection between adding and multiplying fractions. There's a fraction web there, and a card game, and then some number stories. And at the very end, the consolidating thinking was to think about that relationship between adding fractions and multiplying fractions, and to do that by providing some examples. And one more structure is on small group and learning stations. So where we don't have a focus instruction time, and we go right into the instructional routine, learning stations, and a self-reflection. So here is a grade 9 example for polynomials. We start with which one doesn't belong, and they always have to justify their thinking using math. And then the small group instruction was really personalized. One group really was focusing on collecting like terms still, others wanting to work on strategies for subtracting polynomials. It gets tricky when their subtraction sign is outside of a bracket. Some were looking at negative exponents, and some, who were quite proficient and wanted challenge. I was, like, show me how many ways you can do this, right? So that they could share their thinking. So here's an example of what those stations could look like. We had a game 4 in a row. So they name, classify polynomials by degree. There was adding and subtracting using algebra tiles, and checking work either using horizontal or vertical processes. There was an exponent laws card sort, and multiplying and dividing monomials, and thinking about, what could the question be if you're given a solution. And their consolidating thinking was about how the exponent laws help them to multiply and divide monomials, and they had to show their examples. And then for them to actually go back and reflect on which of the topics they explored they need more practice with. Sometimes you can have groups go from one station to the next, or you can have them pick just 3 based on the time slot that you have. So there's more places that you can go on RichNet for resources to support workshop. The tiles at the bottom are continuously being populated over the weeks to come, and you can check back there. As we end, just start to reflect on your own practice. In what ways do you make your math instruction engaging and inclusive for students? How are you supporting students in strengthening their math identity? Consider your next unit of study or lesson sequence. Which of the math workshop structures might be helpful for student learning? And that is it. Join us next time.